All right, let's see. All right. Good morning, everybody. Welcome to the last meeting of 2024 for the SRS. Man, can't believe how this year's flown by. I'm going to, let's see. I'll go ahead and. There we go. Okay. Let's see. This is. Make sure I got the right one here. So get rid of all the unnecessary stuff here. Okay. Let's see what it's. Excuse me a sec here, technical difficulties. So get this thing. Not too loud. What? Oh, it would be nice to, it'd be nice if you could move that guy to some other spot.
Oh, we should bring that.
My grandnephews are playing with Cosmo in the background there, so you're hearing that kind of a funny, squeaky little voice. Okay, here we go. All right, welcome to the December meeting of the Seattle Robotics Society. We'll record these meetings and post them on YouTube sometime, hopefully before the end of the month. I apologize. Sometimes I don't get around to it as early as I like to. But I will try to stay on top of it here. This is the usual agenda that we follow, so I won't bore you with all the details. But these are basically what we'll talk about in the next approximately 20-25 minutes. And then we'll have around the room where you guys can share, and hopefully a few of you got some things. I actually have something I can show today, and then we're going to do a sort of an alternate presentation. My original plan presenter was not able to be here today, so hopefully we'll get them back I'm hoping to get her back in March. So. With that, if you have, if your microphone is on, say, Bob, I see your microphone is actually unmuted there. So if you don't mind muting that for me, appreciate it. If you do have something to share, please drop it in the chat. You can, if you want to, you can raise your hand in the, actually, now that I'm thinking about it, I should probably put up the chat window. It's a really good idea to have that chat window open beside yours there, so you can kind of see when people post stuff in. So if you've got links or any kind of general information, do post them there, and then that will be included in the meeting post on the website. I'm running the meeting this month because Lloyd and Chaz both have personal commitments today, but the three of us kind of share running these meetings, and it seems like that's working out pretty good. And if there's anybody else who's interested in doing this now and then, wouldn't need to commit to doing it a lot, just probably be available a couple times a year or so to backfill. And if you just want to be kind of like the last one we call, that's fine. So anyway, let me know. Reach out to me at the email there on the slide if that's something that you'd be good with doing. I'd be happy to give you that opportunity. I know I haven't added any new places to this list. I know we've kind of talked about these the last few months, but there's maker spaces all over. These are all spaces, of course, that are on your side of the country. I'm coming to you from near Boise, Idaho, so I'm not close enough to actually be able to take advantage of any of these places, but they do have a few of them over here, so have not had a chance to actually try one out. And we have on the website, there is, if you navigate around, it's not actually a real complicated structure on our website, but if you navigate around, there's there's a place where I've got a page of ones that I found. So there, and then there's even one. I think there's a kind of like a national page that somebody maintains that I've linked to, so you can kind of see where maker spaces are anywhere. So if you happen to be looking for one in some other part of the country. And then of course these are kind of generic. Well, the Robot Events website is for national robotic, typically competition events. So they're all over the country. Sunoco Makerspace has regular meetings that you're welcome to attend if it's convenient for you to get up to the north end. And if anybody, we did the last few years, we've done these virtual events where we would have, 20, 25-minute presentations by 4, 5, 6 folks. And if that's something that anybody would like to see happen again, just kind of reach out at our email and let us know that's something. And if you know of somebody or you have something that you'd like to present, it's a great opportunity to just do a short presentation. So you can go on our website and you can see some of the past events where we've put that we've had folks up there. They have their timestamp index so that you can find the beginning of any of the presentations that are in there. Robothon committee. The Robothon committee has actually got a lot more people than this, and I need to update some of this stuff and get a few more actual pictures here rather than just using these avatars. But I will say, I'm gonna, let's see here. Okay, so I'll just go ahead and give some updates. I don't know. Let's see. Is there anybody else? I got Craig, Robert, James. No. Okay. So I will go ahead and give you some updates on the Robothon, from the Robothon committee, and activities that are coming. I missed on my slide. Next event in 2024. Okay. No, I should say 2025. Sorry about that. There are a couple of events planned, and you'll be kind of hearing more about those as next year rolls in, and the committee starts to really kind of dive into planning those. The Robothon website has been refreshed, so do check it out, robothon.org. And Donna Smith has done a great job of just really, completely. She kind of completely went through it and roll it onto a new server, and it's looking good. According to Lloyd Moore, there's 2 in-person contest events planned in 2025. Probably one in the spring, one in the fall. Most likely will be at that Sunnycrest High School where we've been doing them. Although they could be at the First Washington Fieldhouse down in Kent. So just depending on the availability of that facility. The spring, I think it's most likely, if it's going to happen there, it will probably happen in the fall, because the spring they're very busy with First, and they pretty much take that whole facility over, staging the contest, a practice arena, and not really room for a meeting there. So or any kind of a event. So. In case you aren't aware of it, I know Donna has announced it through the Seattle Robotics at groups.io list that there is a separate Robothon specific information and events email list, and I highly encourage that you go ahead and join that. It is. Let's see, if you go onto that website, and there's a kind of an orange button that says join our email list, and just click that button and get in there. And don't leave this one. Don't leave the Seattle Robotics at groups.io, because that's a kind of its own, they're 2 separate things. But rather than mixing event announcements across these 2 emails, we're going to have just the Robothon specific stuff happening and being announced through that list. And it may appear on the other one, but that would be incidental rather than intentional. There's also plans to bring the line following and or line maze contest back. It's been a while since we've done those. We have all of the tiles, and so we'll probably be doing some stuff with those. And then if you go on the Robothon website page, there's 8 boxes of for the different contests. The Robo Magellan, Pop Can Challenge, SRS Build Challenges, Robot Sumo, the 3 kilogram and 500 gram, and then of course the line maze, line following, and so kind of trying to build back up to our sort of our original suite of contests that we've had in the past. And then something to stay tuned for. We'll possibly be making an announcement in January here, but we're working on getting a merchandise website set up so that you can select, customize, and then order online mugs, hats, sweatshirts, t-shirts, hoodies, scarves, whatever kinds of products that the website has available with custom logos. And we'll have a library of logos and images that you can choose from there, and then they ship them directly to you. So just stay tuned for more details. We're having a meeting with the SRS treasurer in January to kind of work out whatever financial commitments that we need to make with regard to that. But that will be an opportunity for you to get some stuff. Does anybody have any questions or anything about Robothon in general? I'll do my best to answer them if I can.
Does anybody have a link to the recent events for like videos for those of us who aren't blessed to live in your area?
Let me see. Did you look in the SRS Clips and More YouTube channel?
No, because that would have been smart.
Yeah, well, I'm thinking. I was just looking at let me see. Contest. Okay, if I bring up. So let's see what past events has here, because it's possible. Past events, mini Robothon. Okay, that's not a link. Okay, so this has got all the, so this has got all this stuff. You get down below here to the virtual exhibitions, and you can see that this stuff here, you can see YouTube video there, but let me see, what do we got here? Build challenge. I haven't actually explored all of this stuff myself, so I'm thinking, okay, so it looks like this is just informational. So,
yeah, I'm actually running into this Seattle Robotics Society channel, which has your logo and has no content. I guess everything is actually on this Clips and More thing.
Yeah, that's interesting. Really, there's I wonder if that was something that somebody accidentally created. Because we've been putting everything on the Clips and More, and you should, it's grouped basically by monthly meeting videos and everything else. There's kind of those two filtering options, but there's quite a few things from past events.
And I do see the mini sumo and outdoor contest clips, so I'll
Okay, good. So I'm glad you were able to find that too. That's good to know that they are up there. And I think it took a little while for that to get done, and it was just a matter of somebody had to go through the videos and edit them and upload them. Just going through the effort of putting them up there.
And thank you to whoever does that. It's deeply appreciated.
Yeah. Okay. Yeah, I'm not sure. I'm not sure who captures those things, because yeah. Okay. Yeah. Well, yeah. Thanks, James. Let's see here. So we get back to meeting. Okay, so on that one, I'm gonna just. And so here this so each one of these boxes will give you the specific rules and objectives of the various contests. And you can see Donna has added line following. I'm not certain exactly what the difference is between line following and advanced line following. So if somebody on the side here wants to just sort of check that out and just say, hey, here's what they're doing different, I'd be curious to hear about that. And then of course line maze. So so not every contest is offered per Robothon event due to space and time. Because Donna, I love Donna's little disclaimer there. Just in case. So the disclaimer is: be sure to check what contests are going to be done before you build your robot. How about that? All right. Okay. Anything else Robothon related, connected, etc.? If not, I will move on. Okay, I will move on. But if somebody thinks of something, we'll go ahead and we can certainly jump back to it. I have tons and tons of suggestions for presenters outside of the SRS, and so I probably, unless you happen to meet or come across somebody particularly intriguing that you think we ought to get on here, I wouldn't be too concerned about that. But if any of you guys want to share something that you're working on, please reach out to me, because we love to hear from members. It's always a pleasure. Thank you, Bob, for your presentation there. That was really awesome. I know. Let's see. I know James has done one or two of them for us, and I sneak in a few, but I usually mine are the discussions, facilitated discussions, which we're going to do today just because of filling in the time. But if any of you guys would like to present, and here's something to consider too, is that we've only been recording videos since about the middle of 2022. So if you did a presentation for the SRS in person back when we were having our in-person meetings, those weren't recorded. And so it would be perfectly fine to present one of those, and we'll get it recorded and kind of put into the archives of YouTube so that people can watch that from forever. So something to keep in mind, because there's been, if you go back, the presentation, if you go back to past presentations and you just start scrolling backwards, it goes back, I'm thinking 15 years, maybe more. So we've got the list of who's presented and what, and slideshows and stuff, probably going back between 15 and 20 years. And we've only got about the last 3 on actually recorded on video. So it'd be awesome to get more of that stuff archived. Open discussions. So today this top one is the one that I'm planning on doing. And I'll lead that. No promises that it's going to be like super awesome, but it was kind of interesting. I was going out there kind of looking at different ways, and it's not necessarily things that people have implemented for robots specifically, but ways that people move machines. And it's really interesting when you start to look at how many different ways you can make something move, locomotive systems. And so we're going to, I was able to find quite a bunch of them. So maybe you'll see even a few of them that you hadn't thought of. So, but if you have any other ideas for open discussions, be happy to add them to the list. And just shoot me an email with your suggestion, and I'll, happy to throw it on there. Okay, so I think actually got this list. I believe I got this list up to date. So believe it or not, about 2 weeks ago, there was I think I only had January booked as of 2 weeks ago. And since then, I've now got February, tentative for March, and April. And so we are, this is looking good for a good start for 2025. So I'm excited about that. I'm just actually, I think I'll talk briefly about a couple of these just because the Builders Roundtable presentations. So what we're going to do is we're going to have 3 or 4 people are going to share in a short 15 to 20 minute presentation their robot building experience. So it's just going to be a kind of a quick, a little bit like the virtual presentations that I mentioned earlier in the meeting there that we did a couple of years ago. Anyway, there's let's see, I'm trying to think. I think Bob Cook, John Jennings, Chaz Eiler, and Donna Smith, I think, are all going to do short presentations. So so do join us for that. That should be great fun. The first technical challenge team from the Taft Sagali High School in Federal Way is going to be doing a sharing about their experience in FIRST, and we have not had a FIRST team on our meeting since we went virtual. So we had we had several teams over the years come and talk to us. And it was fun. It was fun to see the robots, of course, being able to really look at them and have them demonstrate how they worked. And they shared with us, what worked good, what didn't, and their experience. And so that should be great fun. I'm excited that we were able to get a team back again. So, and then I had Dr. Maddie Barra. Let's see. Ooh. I'm not even sure I should attempt to pronounce that without first talking to her. When you start putting that many vowels together, it's like I'm not exactly sure what the best way to pronounce that is. But anyway, she will be. I don't know if she's going to be talking specifically about students' projects, or she's going to bring some students on with her and they're going to share. But anyway, that'll be coming in March. That was going to be this month, unfortunately, but this is fine. And then John Davis, who I just talked to here about a week ago. So he did a presentation last June on AI, and that's what he is like at the center of his job as a software engineer. And he's going to show us how to build basically a portable AI computer system. So taking a small language model and putting it onto a computer that's completely self-contained. So you don't necessarily have to have, you don't have to have internet connection for this to work. And he's had he's actually built one. He says it's surprising how inexpensive this can be done. And I think any of you guys that are thinking about trying to put some kind of AI on a robotic platform, I think you'll find this an interesting presentation. And so he's not a robotics guy in particular, but when we started kind of talking about how we can kind of sort of curve it toward robotics, the idea of being able to create a portable AI system is like, oh, that could be very interesting. So join us for that. And that's all I have so far, but I anticipate that it won't take too much more to fill these in. So as you can see, it doesn't take long sometimes for these slots to fill up. So if you've got some ideas, reach out to me and I'll try to get you into a slot, because love to hear from as many of you as possible. It'd be great. Post-meeting discussion, if there's interest, we can hang out and talk about stuff after the regular meeting, but we don't normally record that. And so I didn't have time to futz around with creating any kind of a slide. So there's my presentation slide. Sorry, it's nothing fancy. I'll put up the first slide of the actual presentation here when we get that far. But and then just a quick review here before we hit around the room. Same Zoom like next week as usual. Of course, the meetings will be recorded and posted on the web fairly soon. It'll probably be up on YouTube, might be up on YouTube before I actually get it onto the website, because there's a kind of 2 separate processes, and it's pretty easy to get something on YouTube. A little more to get the post put together and edit it all out. And if I do make any updates to the website, check in once in a while. help me find presenters, as I mentioned earlier. Any kind of meeting feedback that you might have, and do be sure to post stuff into the chat. And as you can see, there's a. It looks like is that Robert? Okay, yeah, it looks like Robert's been busy posting stuff in there. So there's some really, yeah, it looks like there's some fun activities happening. So you wanted to cover all the bases, James. I see your greeting to everyone there this morning.
I actually have a friend who put on a Festivus party, so got to include him.
So Festivus, what is that? What is
specifically? Oh, that's Festivus for the rest of us. It's it's literally a joke holiday made up on Seinfeld, the TV show. And it includes activities like the airing of grievances, and then the feats of strength. The presents are piled around a pole. It's not a tree, just a pole. I won't say what kind. And it's pretty hilarious, actually. But yeah.
Oh my goodness!
Trying to be inclusive. Trying to be inclusive.
And if it was on Seinfeld, it had to be hysterical. His sense of humor is definitely second to none. Okay, so we're a relatively small group here today. I can share. Let's see. I'm gonna stop sharing here so that you can actually see my ugly face. There you go.
You're rocking that beard, buddy.
Yeah. I have to put on the old the quarter-inch shaver down there about every 2 months or so to keep it from getting a straggly 3/4 of an inch back down to under a half. So,
well, no, see, you just let it go, man. You gotta.
That looks good. That looks good, man. If you just need your elf hat there, and boy, you'd be.
I'm waiting for somebody to tag me to play Santa Claus, and mostly for the joy of saying hell no.
Well, so I don't have the face follicles to grow a really robust beard. Nothing like yours there. I mean, the best that I could do is kind of.
You're looking pretty good there. You're looking pretty good.
It's. I kind of wonder sometimes. Well, what if I shaved it down to like 1/8 of an inch or something? Kind of like that 5 o'clock shadow thing. But I don't know. Does that look good with a white beard?
It's beauty's in the eye of the beholder. So you got to ask the wife or the girlfriend, one or the other, or the mistress or the boyfriend. Being inclusive here.
Yeah.
You know what seriously, what I did is I have a long-term relationship with my barber, and so and I've had 2 female barbers, and they're both absolutely fantastic. And this current one, I asked her what I should do with my beard, and she said this, and I'm like, okay, that's the deal.
Okay. Oh, I'll have to keep that in mind. Maybe next time I go in for a trim on the top, I'm actually kind of due for it. I mean, you can see it's like a let's see. Yeah, it's hanging about 1/8 of an inch over my ear, so it's getting shaggy. So
mine is way further than that. Oh, look at Bob here with his fantastic white beard.
Yeah.
I wear the Santa hat, and I went down to one of the local restaurants down here at University Village, sitting in the window having lunch with a friend, and a number of kids came up and knocked on the window and waved. It's really been fun.
Yeah, that's cool. I haven't. Well, and I'd have to get a red coat. I don't know. This would look like Santa's post-Christmas, shave her back and let her grow out into the following year, kind of a beard. So.
Yeah, I was wearing a red T-shirt or a red turtleneck. Excuse me.
Turtleneck. Oh yeah.
And suspenders.
Yeah. Oh yeah. So yeah.
Doing it up.
All right. So back on topic here. I know we could go off on this for quite a while, but I hesitate to just sort of like, abuse you guys with little YouTube shorts here, and then we go and do more YouTube shorts for the presentation. So I mean, does anybody have anything that they're working on that they'd like to share? Because go ahead.
Somebody said yes, and then
Oh.
so I stopped talking. So who said yes?
Who said yes? Well, I do actually have something, but I mean, I'm willing to take. I'll go last if.
Why don't you go? Why don't you go, and then I'll do mine.
You'll do yours. Okay, I'll break this. Gordon unmuted. You have something, Gordon? Oh, okay.
Sorry, right. Not sure how I got unmuted in the first place.
Okay, no problem there. I just happened to notice that. So, all right. Well, let me let's see here. Okay, share. All right. So, where is it? Oh, I wonder if I. Oh, maybe I have to restart it. Okay. Let's see. I'm going to shut that off for the moment. All right. Okay. And let's see here. I'm going to move this over here and go back to here. And, okay. So you guys are seeing my my little blue guy here.
Yep.
So I did a presentation on this guy for Robotics for Kids about, I don't know, couple of years ago now, when we did our little virtual presentation thing. But and it's pretty much the same kit. I've been doing quite a bit working on it. Let me see if I can. I don't want to unplug the cord here, so let me. I gotta untether my USB cord, because it's already got the software and stuff running on it. And these kits are. Let me get around here so you can kind of see it from the front. I added this servo swivel on the servo, rather than the original kit just mounted the servo pointed straight forward on the front of the robot frame. So I said, well, I tried a thing with three ultrasonic sensors, but it's a kind of expensive upgrade. These sensors are about $25 a piece, with this little circuit board and the little RJ25 plug on the back of it. And you can go on, you can go out on the web and you can find these little ultrasonic modules for $2, $3, right? But when they package it to go with this particular kit, oh, there we go. Now we got Santa Bob on there now. When we it gets to be pretty expensive. It costs $50 to add 2 ultrasonic sensors to this basic robot, without unless you do hard wiring into this module without using their connectoring system. So anyway, let me see if I'll bring this down just a bit here.
So is that basically just because they're making some money when they sell it? Is that the point? I mean, there's nothing special about it.
That's as far as I know. Yeah, it's yeah. I don't. It's basically. I mean, this is an Arduino. There's an Arduino. It's a 2560 mega inside the module on this guy. Let's see. If we go back to. Let's see. Oops. Well, it must have. Oh, there we go. Okay, it keeps kind of switches back behind the foreground here. I'm going to drop that down. So the let's see. You can see these little colored these colored these are the sockets for the sensors. And so they're ports 6 to 10, and then around on this other side, these red ones back here are ports 1 to 4, and then there's a serial COM port, port 5, that's kind of hidden back underneath here. And so what they've done is they pre-wired the Arduino I/O ports to these guys, and I think these five blue, white, yellow, black things are wired to the analog ports, so they can function both as digital ports and as analog ports and as inputs and as outputs. So you could do, you know, a variety of things with them. The other 4 ports are just for output only, so just basically motor control. And so, like, you know, I know you can connect a servo, an RC servo, directly to an Arduino pretty simply. Well, the way they do it, this module up on top here. Yeah, I'm going to readjust my camera angle here. So see this module up on top here? It's got the RJ25 on the one side, and then it has 2 3-pin servo connectors on the other side. So this one right here then just goes over and wires to the servo underneath this thing. And then they give you blocks, and you guys saw that just momentarily. Not on that. Let's see here. Get this. Come on back here. All right, where to go? Hate it when it does that. Oh my. Oh, that's weird. All right, where'd they go? That go over to. Huh. Okay, and there's the 3 desktops. Where'd that go? It's like my sometimes Chrome is a kind of a pain when it comes to really doing stuff. I could probably use a 3rd screen here too, but maybe that would just get me into even more trouble.
Overheat your GPU.
Yeah. So the programming environment gives you function blocks that you can then just link up together to build the programs for these things. And people have created libraries of blocks for all sorts of things. This little 7-segment display right here is an add-on block. This was an accessory thing that you could buy. So this has a little RJ25 socket on the end of it that can plug into one of the I/O ports over here, and the servo port plugs into one of the I/O ports. The distance sensor, the 2 drive motors have their own ports on the end of this module they have feedback. Speed and position that you can use programmatically, but they come in through separate ports on the end of the module, so they don't use any of these accessory ports. And yeah, so I guess what I need to do is I need to see if I can find my. It's saying everything is still up and running, so it's like, okay, where did? Oh, here we go. Okay, there it is. It was all hiding under that one. So, so this is, you know, if you've ever seen, if anybody's ever messed with Scratch or Blockly Prop with the Parallax propeller chip, things like that, you've probably seen this kind of stuff. And it's, you know, it's nifty because you don't have to worry about the syntax of stuff, because all the commands and functions and everything else are all taken care of by all the provisions for these instructions are all built in. So, like, for example, this port one here, you can see there's port 6, 7, 8, 9, or 10. So all I have to do is just choose. It only lets me choose ports that are valid, and all I have to do is choose, well, which one did I plug it into? You know, so when it comes to working with kids, particularly younger kids, to help them to build a program, this stuff it's pretty simple and straightforward to sort through this stuff. These the rest of this stuff here, what these red modules are actually kind of like subroutines. So they're external blocks. So my main program, it looks relatively simple. It starts up here, initializes a few variables and turns off the motors, and then there's a forever loop that starts up there and it ends here. But then when you get into it, then, you know, here's the module called other sensors. So this goes and scans a bunch of the other sensors and loads the data into variables. And then here's one for sensing the distance when the servo is pointed to the left. And here's one that senses when it's pointed center. And here's one that senses when it's pointed right. And these things that goes and it grabs distance readings, and then it sets a state variable that I then ultimately use to just basically tell the robot what state it's in, so that it can then decide what's it going to do. And got to learn how to count in base 3 a couple of days ago. I hadn't done that in a while, so that was kind of fun. And so then these state A. So if the robot is in state A, then it then proceeds to do this. So, you know, this sets a couple of variables. I'm setting my motor speeds at 50% each, and then I'm commanding the left and right wheels to go to those. And then I'm also using commanding the some LEDs on this little ring of LEDs on top of the module to glow different colors or intensity in particular color based upon what I'm telling the robot to do. So before I put batteries, AA batteries into the battery pack, I just hook it up with USB, and so the robot can do everything except actually drive the motors. The only thing it won't do is drive motors. It'll do all the other functional aspects of the program. And as soon as I put batteries into the unit, then it will actually be able to drive the motors, and then that takes it to the next step. I'm not quite ready to do that yet, so I'm not gonna demo that for you. But I will just show you really quickly. So here's my table of all the states, and so the I take the distance. I go and I take a reading from the ultrasonic sensor, and I say, I've got a far variable and a near variable, and so I set 2 distances, and I say, is the distance reading beyond far? Is it less than near, or is it something else, which is between the two? You know, so basically I create 3 states for the reading, and then I call those states clear if it's really close to the robot, blocked if it's kind of near the robot, and then or clear if it's unobstructed, blocked if it's near, and then close is if it's in between. So so I go through and I read the left, the center, and the right sensors and capture those. And then by adding them as, you know, each one of those represents a digit in base 3. The least significant, the 0, the 3 to the 0 power digit, the 3 to the 1 power digit, or the 3 to the 2 power digit. And then I can just add them up and I get a number between 0 and 26. So 27 different states. And then I went through and figured out, okay, for any given state, what I wanted to do. And it turns out there's a lot of overlap. So there's only about 14 different things that the robot actually does. So some of these things are duplicates. So I just test for that. You know, yeah, okay. So down here, like in this case, in robot state 20 and 23 are both drive both motors slow forward at the same speed. So I just test, is the state 20 or is the state 23? And if it is, then do this. And then same kind of a thing. And you go down the list. And so the states are unique numbers, 0 to 26. The unique actions are whenever the robot does the same thing, then I put the same letter. So then I just increment the letter as I'm going through my list here. And like I say, I came up with, I got up to N. So out of all of the unique states, there's only 14 different actions that are different. And you know, so far it seems like it. I believe that it's going to work. let me get back to this guy here, and let's see. I'll go ahead and do the connect. And this is the operation. The USB cable is plugged in. It's in what's called live mode. And so now when I connect it, you heard a little beep there, and now I can run. And so what the program is going to do, let's see here. Let me get back to, oh, did you stop already? Okay. I got to get you back here to my, there we go. Ooh, man, that's really, talk about blowout. Wow. Okay, I'm not going to minimize that like I did before. That made stuff go away here. Let me see. Servo, center left, center right. Huh. Well, there you go. Demo mode. It's been working. It's been working fine. Now all of a sudden.
That is the law.
It is. It is. I
thought I saw the yellow highlight show up when you.
Yeah.
There it is, right? It just. Did you see it highlight again? That yellow outline.
Yeah. The yellow outline will appear around the module that's being executed at that moment. So
it is running.
Okay, so let's say so here's the variable. So you can see across the top there's the distance variables.
So if you move it, then that updates. Nice.
And okay, so it's sitting there. Can you hear the servo motor?
No.
Okay. So it's going and it's taking readings across the top, and then it's you can see the three states here: the left state, the center state, and the right state. So it's going to update those and then adds them together to give this robot state. Then so that gives me a single value that I then test. And then currently I'm calling near is less than 20 centimeters away, and far is more than 80 centimeters away, and then close is between 20 and 80 centimeters. So those three thresholds. Okay, let me get back to, all right, so let me see if I can, I wonder if I can, boy, that, these LEDs on this thing are just like insanely bright. I don't know if I can make any difference here no.
I can still see everything okay. It's just
it's hard to appreciate the believe it or not, it doesn't look like a complete washout to me.
Oh, you're seeing information on those LEDs is the point.
I am. And like, for example, there's the number 12 is showing up on this. So that's the current state. That's the robot state that's showing up as 12 up there on that display. And I can choose anything. I can put any kind of data I want that'll fit on a 4-digit display, and I was just kind of hoping. It's like, it's really, it should be kind of more or less continuously scanning this guy back and forth, and it's just going really slow. And it may be because I'm trying to do Zoom and other things. I'm probably way overloading this poor little computer here. So I probably need to be doing this on a completely separate computer, and eventually I guess I will. Okay, I'm just going to go ahead and shrink that down. Oh yeah. See, now as soon as I minimize the video, now it's scanning.
Now unfortunately you're seeing the actual numbers. Yeah.
So let's see. Okay. So let's see here. If I went, okay, let's do it this way.
Oh, much better.
All right.
You can definitely see the state at least.
Yeah. Let me see if I wonder if I can. Okay. Got to make myself big enough so that I can see it and see if I can find a. Yeah.
Yeah, I can see LEDs changing in the middle area barely.
Yeah. So the three front LEDs, what the three front LEDs are going to do is they're going to glow red, yellow, or green. Green for clear, red for blocked, and then yellow for close. So it's going to give me, as it gets those readings, those three readings, it's going to indicate it on those LEDs. The two side ones at 3 o'clock and 9 o'clock on the ring are the motor speed, and so I'm scaling the RGB for green from between 0 and 250 based upon the percentage. So 0 to 100% times 2.5 gives me 0 to 250. And so then depending on what power level I'm telling the motors to drive at, that'll light those LEDs up. And then there's a couple more just behind them that are a couple of light sensors that are built into the top of this module. And I can put my fingers over these things and make them get dimmer, or I shine a flashlight on them and make them get brighter. And theoretically, this little Lego brick on top here is a separator. It's an optical separator, so that if I wrote a program where I could shine a flashlight at this thing, I could move the flashlight off center. The one light sensor will see more light, the other one will see shade, and then I could make the robot turn and go toward the bright site. Sort of try to line itself up to go towards a light. Make it basically a light chasing kind of a thing. So anyway, it's kind of it's coming together. Yeah, it's actually doing okay. So now it's scanning quite reliably now. So it's the video from this extra camera up here seemed to be really hosing things up. But it's been a fun kit. I've had a good time. I'm thinking about starting up some in-person classes here again in Idaho, with some local kids to use this kit and do some more programming, because it's a surprisingly capable. I mean, it's an Arduino 2560 megas it's a pretty respectable version of that Arduino chip. Lots of I/O. I'm not sure they don't make stuff accessible, though. I'd have to bust into the case and solder wires to the circuit board, I think, if I wanted to get additional I/O out. So and for purposes of teaching a class, I think I would just as soon keep it as simple as they have it here, where there's crossing wires is pretty much a non-issue. Because of the way they've connectorized this thing, there's pretty much no way to break anything. So it's good for kids in that regard. So okay, I'm gonna go ahead and take that back. So anyway, anybody has any questions, I would be happy to entertain them if I can. Otherwise, I hand it over to James and give him 2 minutes and 30 seconds to tell us what he has.
2 minutes and 30 seconds. Okay.
You can have a little more than that if you want. I'll give you 3. I'll be generous. This is Christmas, right?
It's Christmas. Thanks, buddy. You're a gentleman and a scholar. I take back half the crappy things I've said about you. So there's this project that I've been working on for forever, which I just called the hybrid disk encoder. It's based off of the encoders that we use on the Dexter robot arm, which are stunning in terms of the CPR. We get more than 1 million CPR on certain joints on the robot. And so this is real simple laser cut parts. I didn't want to use 3D printing because we have to use the FPGA on the robot to compensate for the variations in the 3D printing. And the idea behind the laser cut is that it has high precision. We've also made these encoder discs out of PCBs, and that works really well as well. They have a nice clean signal. It's not obvious. I don't really have a picture of it here, but the shape of the mask that is hidden inside this hub is also really important. These are just standard rectangles here, but the masks behind the LEDs and optosensors are a very critical shape. Yeah, there's a link to it there. I'll get into that later. It doesn't really matter. The electronics are just super simple. I mean, I didn't even bother drawing a schematic because it's just, there's a resistor, a capacitor, an LED. There's an ADC input through a voltage divider to the optosensor. Nothing. I mean, it's just nothing to it. Originally, the processor, was the FPGA, but I tried doing it with this PSoC4. Unfortunately, that coincided with my getting so mad at Microsoft that I devoted myself to Linux, and they only have a Windows-based thing. So I'm like, okay, never mind. I'm not going to do that. So then I started messing around with the Pi Pico, and thanks to Earl Philhauer and Walkway, it is stunningly easy to program those things, and they run real fast, and they're like $5 in quantity, $10 in singles. So
Wow.
I mean, like that's like the whole development board, right? Like with everything on it. So it's just like, wow, why not? So anyway, long story short, it works. There's the proof. And I know that this is a really bumpy signal, but like the yellow or orange value there is like a sine. This blue green is the cosine, but the one that's important is this value number 5, which is this red line, and you can see that sawtoothing. So this rapid vertical transition right here in the middle is it's switching from one slot to the next. Okay. And then this long slow descent, which is relatively smooth, is roughly 1,000 different points from one side to the other. So that line is at 1,024, that orange line right there. And this is 0 down here. So we're getting roughly 1,000 from bottom to top. And that line right there is representing the position between or inside of a single slot. Just want to make sure that's absolutely clear. Okay, this is not counting slots. This left side over here is one slot. This right side over here is another slot. That's telling you where you are inside one slot. So I get 1,000 positions. Let me say this one more time. Inside one. Can I make it more clear? Okay. So there's 1,000 positions per slot, and there's 126 slots. So that's 126,000 CPR.
Yeah.
Okay? So, and again, the fact that it's not smooth is, I believe, due to stiction, because I have seen randomly, which I failed to capture, some very nice smooth ones as I moved it as smoothly as I possibly could with my finger. You can't move it very much, right? Because then you're going through a full slot, right? So you have to, you just barely tweak in the thing. So a couple of insights about, and then I'm going into single track gray code to get absolute position, but that's another thing. The thing to keep in mind is this is providing an absolute position within the slot, right? So I don't know which slot I'm on necessarily, but I know exactly where I am inside that slot at all times. There's no so I've added quadrature decoding to this so that I can, I'm keeping track of which slot I'm on as I go past one slot to the next. But which slot did it power up on? Well, the single track gray code thing will potentially solve that. And I've done some work on that. I'm starting to work on that. But more importantly, there's a couple of weird little insights that I want to get across. The slot has to be the correct shape, and that is really freaking confusing. But basically, the mask has to be this shape right here. What we're doing is we're passing. If this rectangle is the slot on the encoder disk, and this is the shape of the mask, what I'm computing here is the overlap between that slot and that mask. And this particular mask shape gives you almost a perfect sine wave, which is what we want, because we want a sine and a cosine, and then we get a circle, and they were doing the atan too. Anyway, so that's an important insight. And then the other important is that on the robot, we don't have issues of oscillation on the joint very much. Okay, there is a little bit of oscillation if you turn the gain up too far, but we don't have a ton of oscillation in the joints, and we're not doing any. We're not doing a complex control system, right? So it's not even a PID; it's just a P. There's only a proportional gain signal. We do have digital friction, but we're not really using that much. So the question is, why doesn't it oscillate like all heck if all we have is a P? And if you think about it, in a PID controller, the I and the D both have a time element to them, right? So the I, it's like, how long have I been off the mark, right? And with the D, it's where am I going to be, right? At what point have I gone too far, right? What's the next time step going to be? As your control loop moves faster and faster, those elements then start to drop out, right? Because the time element is lower. Think about it this way. Like if you had a control loop that only updated once a second, right? You would have to have really good predictions about where you're going to be the next time and about where you have been in the past, right? That would really, really matter. As your control loop goes faster and faster, suddenly you don't have to have that really good protection, because the instant something goes wrong or is about to go wrong, you can already start correcting for it, right? So I had always believed and kind of been told that the reason why the control system on the robot does not oscillate, despite the fact that it doesn't really have an I term, it kind of does, but it doesn't have a D term at all, is because the FPGA provided such a fast control loop. Well, I don't think that's true anymore, and that's the next thing I'm gonna to investigate. And the reason, somebody tell me if my thinking is wrong here, is the reason is that there are two sources of delay in a PID loop. The first source of delay is the time that it takes to do the reading, calculate the response, apply the response, the standard, that's the obvious one, right? But there's a second source of delay. Imagine that you have a joint with a 360 CPR encoder on it, like a really low resolution encoder. So you get 1 click per degree, okay? And let's say that your joint is currently sitting still at just clockwise of 0 degrees, okay? Now, something comes along and pushes on the joint. You have the time that it takes to go from just to the right of 0 all the way over until it ticks at 1. That the time that it takes to move that full degree until you get a signal that anything has gone wrong.
Right.
So what I'm saying is that low resolution encoders introduce a delay into the control loop. This is to me like a key insight that in all my years of doing robotics I had never thought of, right? Maybe somebody else that was obvious for, but it hadn't dawned on me. So the reason why the robot doesn't vibrate, and I should say, the super high resolution encoders that we have, right, mean that nothing can go wrong before we know about it. Like the instant something goes wrong, we know about it, right? There's very, very, very little delay from the thing. And so I started looking at like what the delay would be on a low resolution encoder going into a control system. That delay swamps the computational delay by like orders of magnitude, like 2 orders of magnitude. Okay. Having a high resolution encoder, is the thing that makes the joint not vibrate or oscillate. And so I'm pretty sure that the Pi Pico, and that's the other thing, is like when they started designing this robot, I mean, it was 10 years ago that they first came up with this design. And the FPGA at that time was probably necessary because honestly, we just didn't have super fast little microcontrollers, right? I mean, there was the Scenics SX, but that's, turned into the propeller and all that. All right. Yeah. Okay. You can tell me to shut up, Steve. I know.
No, I just checking the time there. So
Yeah, okay. Yeah, don't hesitate to cut me off.
We'll do about a 5-minute break or so just to get things rolling again. So go ahead and finish your thought there.
Yeah. So today we have like the Pi Pico, which is running at hundreds of megahertz, and there's other chips that are low cost that are even faster. I mean, you can overclock a ESP32 and go even faster if you want to. So the point here is that compute has caught up to the point where I really think that it should be possible to do the whole control loop with the fantastic precision, with the really good response. And the key is in robotics, if you need to have an I and a D term, or if you need to do like more complicated like input shaping and feed forward control and all these other fancy control systems that have tuning elements in them, you can't. Why? Because the robot's circumstances are constantly changing. It's picking up a different load. It's in a different kinematics position, right? So where there's no gravity here and there is gravity here, right? So all these things are constantly changing. So you have to have something that works with a really simple control system. And that's why I think this can be done. I think it can be done for super cheap, and I'm super excited. And I hope that what I have learned from people far more intelligent than me will be able to be applied to a greater degree in the world. Like other people will be able to take what I'm translating from these geniuses and put it to use.
Okay.
Yeah, cool. I'll post a link to the repo, or actually I already did. Never mind.
Did you have a question, Doug?
If you went back to the picture of your encoder, what I'm surmising is your LEDs, or sorry, your photo sensors are quite far apart. So each of them is looking at a different hole.
Yes.
But
yes. So
the relative distance is a quadrature, right? So
exactly.
Which is interesting. Yeah. So you had to be very careful in how you place those holes relative to the scale of the disc.
Exactly correct. That's a great insight. The issue there is, if you're doing a 3D printed disc, which we were really locked into for a long time, but we finally have kind of given up on that. You were comparing like slot 1 with slot 4, and like slot 1 was giving you the sine wave and slot 4 was giving you the cosine, because your spacing is 4 slots plus 90 degrees plus a quarter, right? So the issue is that the 3D print distortion on slot 1 and on slot 4 may not match.
Wow.
So like you were never going to get a perfect circle, because we're plotting sine, cosine on the x-axis, I think, and sine on the y-axis, so that we're getting a circle, right? And then we're doing atan 2 just as a way of combining the sine and the cosine. atan 2 gives you the distance from the point you're currently at on that circle back to the center point. And so that gives you like 360, like how many degrees, but it's not really degrees. It's just, what percentage of 2 pi are you from moving from one slot to the next? And so we would have all of these distortions because this slot and that slot don't match, right? Now, using the laser cut parts, my hypothesis, and I haven't completely proven this yet, but the early returns are looking good, that it's consistent enough that it doesn't know that slot 1 and slot 4 are 2 different slots, right? In other words, they look so completely the same that it doesn't really matter anymore, right? So yeah.
Wow.
So do you have any trouble with the sawtooth not being monotonically decreasing along its long diagonal run?
So far, no. So far, it seems like it's okay. I do, if I let it sit, if I just let it sit still, I do see noise. So in that case, yes, you'll see it vibrate back and forth between like 2 or 3 different values, right? One of the things that I'm working on right now is building a metal enclosure, because right now all of this is just on a whiteboard breadboard, right? So There's a lot of analog noise in there. And on the robot, it's a 12-bit encoder. I'm only using a 10-bit encoder, so ADC. So I think that hopefully I can get down to the point where there's very little noise. But also, every once in a while, and this is another thing that I was really amazed when I learned this, actually many years ago. A lot of times, noise is a really good thing because it keeps you from locking up. It keeps you from having stiction problems in a joint. If it's just always kind of vibrating just a little bit, as long as the vibration is small enough, right? As long as it's not big enough to actually cause problems. So yeah, there is I think going to be a tiny bit of that. I don't think it actually matters.
Okay, well, I'm going to jump in, and I want to. Yeah, we've got about a short break here, and I'm going to go ahead and load up the discussion. We'll see if we actually get through it. Something to kind of mull over here before we get started on this thing is different things that you've seen out in the world, and crazy ways that people have made robots move, and I haven't haven't captured all of them by any stretch. So, but I am going to let's see. So I have. Okay, it's about 11:13 your time. So I'm thinking it's about 11. Take about 5 minutes. So about 11:18. I'm going to get this thing rolling again. I'm going to run to the restroom and refill my coffee cup, and then we will embark on this, and we'll see. They might split this into a couple of parts here. If I don't want to push too far past noon, or noon for you guys. So it'll be 1 o'clock for me. So. All right, so be back shortly.
You're muted, Steven.
Yeah, I'm trying to kind of figure out how the best do some of this stuff here. So, well, we'll see how it works. Okay, let me see here. We had a busy time around my house today. There, we've had a couple of my grandnephews spending the night with us, and I've got a bunch of these cool robots back here. I think I've showed you guys some of these things. There's a 4-legged walker, and then there's a little Cosmo, and we've got Kinects, we got Legos, and they're just having a blast, using their hands and their minds. It's like, okay, this is awesome. You get kids off of screens and get them to doing real things with their hands, with their brains. Okay, I think it's about time. All right, I'm going to go ahead and get things rolling here. Let's see. I think I'm gonna. It was just sitting there. It wasn't plugged in. So it's only 19%, so it's not going to run for very long.
Oh yeah.
Plug it in over there. Okay. Sorry about that. Some of these robots use smartphones as remote controllers and stuff, and so I've got a bunch of old cell phones that I'm using for that. But of course, they almost always have dead batteries that have to be recharged before they work, and it's great fun. Okay. Robot mobility system. So I will, as a disclaimer right up front, I'm no expert on any of this stuff. So I've messed around with a few of these things, but this is an opportunity for you to chime in. Hey, this is the stupidest thing I've ever seen, or there's no way that could ever work, or please feel free to just jump in and put in your 2 cents worth, because that's what this is about. It's I'm not proposing that any of these things are particularly good ideas. Some of them you might find interesting, I hope. And so anyway, with that, I will kind of roll along here. So okay, so let's say for your very typical common, start off with the basic thing. And I don't know whether or not, I suppose I don't really even need to play a video for this. I went and tried to find some simple video, but, a couple of motors, gearbox connected to wheels, the kind of the basic thing. How it depends on how many wheels you choose. Okay, that's going to be a little bit further in. We'll talk about that, whether you balance on 2 or use 3 or 4 or whatever. Always a very simple go-to option. I mean, my little robot that I showed you earlier, it's got 2 drive wheels and a caster. So, it's basically three wheels, 2 driven. Very simple, stable. Don't have to worry about the thing falling over when the battery dies or anything like that. So that's your kind of your basic entry level, and most inexpensive, simple robot kits that you might find out there will probably use something like this. But now let's say you want to go and do something a little more, a little more interesting. And I suspect, are you guys hearing audio on that?
No.
Okay. Well, it's just music. It's interesting. I can hear the audio, but apparently, they're not saying anything. They're just showing. And this is kind of cool because you see how it actually has the rear articulation there that allows it to squat and go underneath things, which is it's kind of a cool design. So it's not only balancing, and I don't know, it might even actually. Well, I don't know. You could tell me. Does that help, you think, in terms of the dynamics of balancing, to have the legs be able to bend like that?
As I understand it, the calculations change depending on the height. So I think it actually, in other words, your computation for balance has to be flexible in order to accommodate the changing height. I saw one of those, by the way, at CES that had a feature I really kind of liked. It was maybe just a little bit bigger than that one, and it had a hard attached wheel on the nose and on the back. And so it could collapse all the way down, and then it would be running on 4 wheels, one center front, the 2 on the side, and then 1 center back. And you could sit on it and ride it around when it was in that mode.
Sure.
So the guy had it set up with a microphone, and he would go, "Come here," and it would come over to him and sit down, and then he would sit on it, and then he would drive it around, and then he'd let it go, and he would go over there, and it would go where he pointed. It was cool.
That's pretty neat. It's this. I was surprised that this is bigger than I originally thought. When I first saw the video, when it starts out, you don't see any kind of anything for real scale of reference, and then when the people come into the scenes there, all of a sudden you realize, wow, this thing is actually a pretty good size.
Where would you say the wheel motors are?
Well, yeah, that's a good question. Okay, let me see if I can find a spot.
I think they're going through a belt drive back up to the knee joint and then passing through up into the actual body of the thing, or at least that's the one that I remember seeing. That's how they did it.
Quite a route.
Yeah, there's a lot of drive transmission work that you have to do to make that work.
You could see that would work well for the motor built into the wheel setup.
Yeah,
I wonder, maybe they do that here. Because, I mean, a BLDC would fit in that pretty well, wouldn't it?
Yeah, maybe. I don't know that. Yeah.
Can't see enough of it.
Yeah, it'd be cool to get a closer look at this guy to really get a.
I may be wrong, but I think I'm seeing a belt going from the right there. Is that a? Oh, maybe it's not a belt. I thought I was on the inside edge. I thought I was seeing a belt.
Yeah.
Maybe not. It's just the green plastic.
Yeah. Yeah, not. I know it's kind of a, it's a neat platform. I mean, it's just this. I wonder. Well, it looks like it can. It looks like so you've got a pivot. You've got a pivot joint back here. You got this one here. You got this one down here, and this one here. So that's going to limit how much it can straighten up. So I mean, it can only go. I don't know how much. It looked like it could squat down pretty good.
So the only one driven is that lower left, middle left one, right? That's the one that's driven. The others just follow.
Yeah. Yeah. So I suppose that's probably just a servo or something underneath there, or maybe a servo on each side. However they're doing it. Huh. Yeah. And the other ones are all just passive joints.
I would love to see that thing make a tight corner quickly by dropping its inboard wheel.
Oh, you mean like leaning into the turn?
Yes.
Yeah. I've seen robots like this that have done. There was one, I remember a video of it being out in the woods and then going into a parking lot, and in the woods it's bouncing down a hill over really, really rough terrain and staying up, and then it gets into the parking lot, goes over the bump where you park, that cement block or whatever, and then it goes, and then it takes off, and it leans into a corner as it takes off. It was a pretty cool video.
Wow.
I think this is the design that's going to carry out the execution orders on human beings when the robots take over. This is the very mobile, fit in any space, great dexterity, just enough space on the top for a machine gun.
Oh man. You get something quick because we're wind it up. Go ahead. Yeah. Okay, so two-wheel balancers are just fun. I'm thinking could it have been a Boston Dynamics robot perhaps that you're thinking of? Because I'm thinking I saw a video like that too.
There was, but then I think that was a Boston Dynamics robot that was doing that. The other one that comes to mind is Boston Dynamics. What's it called? Stretch? No. It's the one with the battery, the big fat butt that's filled with batteries. And there's a video of that one coming off of a table. And it's got these tiny little knee joints, and I don't understand how that thing didn't blow its knee joint out, because you can see it come off of that table and land on the floor, and it's just bam. I mean, it's a drop of 3 feet minimum, and I'm like, what did they make that joint out of that it didn't just explode? Amazing work those guys do.
Yeah. Okay, well, here's our okay, now here's maybe somebody can clarify this from a semantics here. So they call mechanism, they've got mechanism and holonomic. Are those interchangeable, or are those actually two different kinds of this type of wheel? Does anybody know?
Yeah, so those are the one on the left is mechanism, and the ones on the right are all what I would call holonomic.
Okay.
So holonomic means the unpowered wheelets just allow the wheel to move at right angles to the direction of rotation. So you can import force on the robot in the direction of rotation without constraining it in the other direction. So as few as 3 of those on a robot allows you to move in any direction and rotate arbitrarily.
Okay.
But the mechanism wheel, I think you might be able to do it with 3, but no, actually, because I think in order to use the mechanism wheel, you need to have opposite. You'll notice how the wheelets are slanted. I believe you have to have at least a wheel with the slant one way and a wheel with the slant the other way in order to work. And you probably need to have 2 of each in order to keep it from rotating when you don't want it to.
Okay.
But the idea is that you can drive them all forward in order to make it go straight, and drive them oppositely to make it go sideways.
Mm-hmm. Right.
So I think the first use, or one of the first uses of these, was on a forklift, and you can actually move in all directions with a forklift.
Wow. I'm well, let's see here. Well, I got another video here. Let me run this one, and let's see what this is. And you guys you'll love this.
Oh yeah, I've seen this.
Yeah. So I'll just leave the closed captions up there so that you can this is really slick. Okay, so somebody with a 3D printer needs to make some of these guys and do a little demo on this, because this is just cool.
Keeping in mind that that's not being like internally actuated, right? I mean, that's just happening automatically.
It is. It's passive. Yeah, it's completely passive. And he'll show you, when he gets a little further in here, he'll show you the mechanism that they printed in there to make this work. And it's slick. And so right now he's talking about the difference between these two kind of fixed wheels. And then, of course, you've got these, there's all kinds of different transformable wheel designs that people have used and tried. And, they have different advantages. But now here's how this one works. So there's kind of the geometry of it. Now see that little strip in the inside. So watch what happens.
Is that a spring clip in the middle? Yes.
It's just more material. You know, it's all part of the print.
Hmm.
So it isn't added. Now I would kind of wonder, okay, maybe you would want to have something a little more permanent, maybe some kind of a little metal clip or something. So there's your, you know, this is kind of like a transition between what they call the wheel and the weg. So one of the things they looked at is power consumption, you know, and it turns out that having those like 4-prong type wheels uses more power than one that's got round wheels. And so that's that's advantage number one, is that because it's mostly round, it behaves like a round wheel. It's very efficient from a driving standpoint. But then because of the way it can transform,
many years ago, I made a Lego model of a robot. I think it was a Japanese robot that had 12 wheels, each of which just had several rods that stuck out from the center. So close to that WEG. And by having 12 of them at different phases, you always had enough legs down that it would travel smoothly on a flat surface. But then the horizontal position of the various wheels was positioned so that if you came to a standard staircase, it would the rods that stuck out from the wheels would engage the stairs. And so it had to be tuned for the size of the staircase, right? But most staircases are pretty standard for humans. So my model was not full scale, and so it didn't work on a real staircase, but it would have worked on a scale staircase.
Huh. Yeah.
But this looks like it. Well, so when do they use the WEG? Yeah, I would think with the WEG, you would need to have redundancy. You'd need to have like 8 wheels so that you had one of the wheels would be down when the other one would have its gap.
Now that could be, yeah. I'm not certain. Let's see.
And of course, the hybrid is another way to do that. Just have the hybrid wheel, and it is round until it needs to not be.
Okay, now this is interesting. Now look at the picture on the left there. You'll notice that all
only
4 wheels are oriented the same. There's no. Now, what difference might that have made if they, let's say, maybe took the two diagonal wheels on opposite sides and rotated them with that 45 degrees so that their feet essentially would be down, touching the ground when the other 2 were up. And I wonder whether that would make a difference in the power that it takes.
Yeah, we're not seeing the smooth video, but watching that, how bad is the bouncing as it goes along?
Well, let me back it up just a sec here. Okay, here we go.
I think it's actually pretty smooth because the outer wheel, when it's not activated, is perfectly round. Look at the back wheel in that video on the right.
Oh, no, on the right, that's round, but on the left, that's what I'm trying to figure out.
Oh, I see. You're saying in that example, then yeah, I think that's not terribly smooth, is it?
Yeah. So, but with redundant wheels, you can make that smooth.
Right. So between all of the wheels, there's always a surface on the ground. But I think that the point here is that I don't think he's advising us to use that. I think he's saying, this is what's good about this one, and this is what's good about a round wheel, and now we can get the best of both worlds by putting them into this one compliant mechanism wheel.
Exactly.
That then can climb over things when it needs to and be round when it needs to.
Yeah. I think I agree. That's
yeah.
You know what this is a great example of is something that I'm always like advising people, and I think it's ignored way too much. This is mechanical computing, right? Like there's digital computing, there's neural networks, there's digital computing, digital logic, there's analog computing, which is overlooked, and then there's mechanical computing. And this is a great example of mechanical computing.
I won't do this next video. I'll do just the first part of it because he just kind of demos.
So this is Mechanim.
Yeah. And these are always kind of fun to watch because and I have a couple of Omniduino robots that have these kind of wheels on them, and if you go to their website, you can they go through a tutorial explanation of how to drive a particular kind of motion using those wheels. You know, I mean, it's essentially it's algorithmic, right? You turn this wheel this way and this wheel this way, and the robot will do this, and then you turn this, you know, and it goes through and it explains the whole how to make a robot move any given way based upon how you want, you know, how you drive the wheels. And in most of this video, he just talks about making this thing because, as you can see, it's a 3D printed robot, and he goes.
Is that a 4-motor robot?
I believe so. Yeah. Yeah. See, it looks like down here.
Yeah, you can see them underneath. Yes.
Yeah. So this has got one motor on each wheel. And I think you kind of, I mean, to have full control of a robot with Mechanim wheels, you pretty much need each wheel independently drivable. So, yeah.
So the forklift I was talking about, I'll bet it has hydraulic motor on each wheel, and so you have one engine or motor driving the hydraulic pump, and then hydraulic motors allows you to have full control of each wheel individually.
Right.
Ooh.
Oh yeah. So this one, yeah, I know I've showed you guys Festo videos before. Festo is an amazing company, and these guys, whoever the people in their robot research department, you know, they love to create bio-inspired robots, and this one's intriguing. So this is the one on the right, picture on the right. That's what this thing can fold out to. So it can literally fold out to like a spider type of a robot, type of a creature. And then it can pull those legs in to be able to do what.
Now, so do they power that? Well, is that one wheel of a multi-wheeled robot, or is that one robot? I think it's one robot.
It's actually one robot. They call it the bionic wheelbot. So it's inspired by, like, for example, this little guy. So this is a little spider that kind of does this rolling thing, you know, when it's fleeing from a predator or something like that. And so they're engineers, and let's see what we can do, you know. So they I don't know if this particular one uses their air actuators, because that's kind of what those guys are known for and specialized for. But I mean, this is just cool. I mean, the thing is, this is like, okay, you talk about like a transformer, you know, totally awesome transformer type of robot. Oh my goodness.
So they've actually stowed one of their legs on each side, so they only have 6 legs down of the 8.
Yeah. And so now it's walking using its 6 legs, 6 of the 8 legs.
I wonder if they are thinking about manipulating things with those 2 extra legs.
Maybe. And look at that, and you can do and of course with the, let's see, they got to have, so well, I don't know, wonder how many servos has that thing got on it.
Yeah, well, that's the problem with these, is there's a lot of servos there.
Well, 2 per leg, I would say.
Yeah.
At least maybe more.
So now here it's transforming into Wheelbot.
Yeah, how does it rotate those elbows?
So it uses those extra 2 legs. You see how it's pushing itself on the extra 2 legs on the outside there?
Oh yes.
How cool is that? Off the table. Whoops! Better work on those. Better work on those cliff sensors.
Yeah.
That's another one that I can see in the next Terminator movie.
I know that's one of my of their robots. This is one of my favorites. I mean that thing is just it's too cool. It's like, is that a leg robot? Is it a wheeled robot? Is it what is it?
Imagine having multiple cameras, not positioned, just around the ring, and then de-spinning that in software so that you can figure out where you're going.
Yeah. Okay, so then legs, of course, are handy. Legs are a handy way of dealing with the more challenging terrains that you find in the outdoors. It's trying to make something with wheels that can drive over things. It kind of works, but if you have small wheels, especially if you ever try to take a robot that has little wheels and go outdoors with it, they usually don't work so well. And but then with a leg robot, especially a 2-leg robot like this, to be able to take it outdoors and have it be able to walk around and balance itself, that's a whole different challenge.
They put eyes on it. I would call this a robotic pair of pants.
So this particular robot is not actually those were Boston Dynamics up there, and you guys have probably all seen those. But this is a little guy that this College of Engineering students apparently have put together, and they're trying to look at real world applications for these things. You got some, you need to send a robot in a place that's kind of dangerous for people. So something that can crawl over rocks, debris, that sort of thing. Oh, okay. Yeah. And so there. Well, look at the feet on that thing.
Is that another example of a compliant mechanism, or are they using joints? Like actual, like bearing. Huh. Yeah, no, it looks like it's actual bearings.
How many?
Look at love all these little magnets in the feet there. They're
ballast.
Ballast, yes. And because see, they're relying on the dynamics of the rolling across the foot and then swinging the legs in the proper timing so that it's able to.
So there's no articulation between the foot and the leg.
Nope. That's really quite clever. I that. Okay, and then use cameras in the area to remotely control a thing, then to get it to go where you actually want it to go. That's really a pretty impressive project. I've seen the robots where they where it leans, it's essentially statically balanced. It can statically balance on each foot, so it can stand on one foot and then lean over onto that foot, lift the other foot up, move it from behind to in front, and then set the foot down and then kind of go back and forth. But it's always has a fully static balance. It's not relying on the dynamic like this guy does, where this thing can stand. It looks like. I'm guessing that there's nothing that prevents if the robot isn't moving, it looks like it will stay upright. I mean, there's enough weight in those feet so that the CG is down low and the feet are wide enough so the robot won't fall over. But then it starts to swing those things. Oh, this is a different video. Okay. and then it can move itself using the that dynamic pendulum effect. Pretty neat. I think they did I think students did a good job on that one. Treads. This robot kit that I have has a configuration where you can actually use treads on the thing. It turns out that the biggest disadvantage of treads, though, is the amount that it takes a lot of extra power to make them go.
Yeah, they're very low efficiency.
Very low efficiency. Yeah, very stable, capable. You can go over a lot of different kinds of terrain. So in terms of building a machine that can go places, sure, but you be prepared for a pretty heavy duty power hit.
About half of that inefficiency actually comes from using like rubber instead of using actual segmented treads. So that one on the left, I would guess, is probably more power efficient than I think the ones on the right, which are using what looks like I can't really tell from the diagram. All I'm saying is if you have the little articulated individual segments, those are typically more energy efficient, but they're still not great.
But
what you do get is fantastic traction. That's the big advantage.
So someone once told me, you remember pedal cars, right? When I was a kid, I had a pedal car. And what this guy was saying is, you've never seen a pedal tractor, right? A pedal that is a pedal, I don't know what you call it, but with treads. And the reason, by the time you made it strong enough so that it wouldn't tear itself apart, it would be too heavy to have a kid power it.
Exactly. Right. Yep. That's true.
And I wanted to say about you had earlier a four-wheeled robot, and in one of the first teams that I helped with, we made a four-wheeled robot, and what we found was that the available motors were not strong enough to turn that robot because there was too much traction on the four wheels. And our expedient solution was to encase the front two wheels in epoxy so that they could then slide horizontally across the ground in order to be able to steer the thing.
Well, that's where your holonomic.
Yeah, if we'd had holonomic wheels, that would have been the other solution. But this was cheaper, and we already had the stuff.
Oh, this thing, Steve. Wow. Yeah. The crazy plumber over in the UK, Colin Furs, built one of these. And his experiences with it are just hilarious. If you get a chance, I strongly recommend that video.
It's fun to go look these guys up on YouTube because now as you might guess, the one on the left I think is a model of a machine that was built back a long time ago, I'm guessing. The one on the right I think is a toy that I don't know when that would have come out, but the Archimedes screw. So
in the 20s, I've seen a video of someone took a Fordson tractor, which was an old four-wheeled tractor with a transaxle. Actually, the whole that had two halves of engine and transaxle all in one container, and had four wheels on it. Someone took one of these Fordson tractors and replaced the wheels with pontoons like that with a spiral, and we're able to go around on snow. That it rides over the snow, and they showed examples of horses where the horses would poke through the snow and be immobilized, but the Fordson tractor with the pontoons could go over the surface. So we actually made a power tool racer that was based on this principle. We didn't have pontoons. We just took 1/8-inch rod and bent it around a pipe, and ended up with two spirals counter rotating. And we drove each with a drill motor, one on the front and one on the back, to balance the thing. And we were able to go down the power tool racing track with that. Yeah, so he went right through the snow, but the pontoon device sits on top.
Yeah.
One thing I've never really heard is how long those things can possibly last, because I mean they're encountering a lot of friction and scraping when they're moving
You need a really slick surface somehow, yeah. But
yeah, the snow I guess would be fine, or ice or water would probably be fine.
Yeah. And it's kind of cool to think about, sort of like with the holonomic wheels, if you drive them both in the same direction, and now your vehicle can move sideways.
Yeah. And you could steer and move forward or backwards. So yeah, it's pretty good. But like James said, you need to have the slide.
Yeah. It does seem like it seems like a best suited for a softer kind of terrain. I mean, gravel, rocks would rip those things apart. Those screws they just wouldn't last. But send this thing out in the mud or put it on the water or.
Now you could imagine a version with wheels along the rib that would work on a more solid setup. But then, of course, that would be a lot of wheels. And, of course, it would get mucked up if you then had to use it on a soft surface.
Basically, a holonomic wheel, but extruded into a screw shape.
Yes.
Right.
Yeah.
Oh, my goodness.
Well, there's your $1 million idea.
Oh, man. So anyway, that one, I figured you'd like that. Now, I have never seen or heard of a robot that used that mechanism. I mean, it doesn't seem like a particularly energy efficient, drive system. So my guess is that, probably not the best choice. You guys have probably seen these little gyroscopic cubes. And of course, if the thing is controlled so that it can flop itself down on a given side, then it can literally walk.
So is this using what do you call them?
Gyroscope.
Reaction wheels.
Oh yeah, reaction wheel. That's the better word for it.
Let's see here.
This is another one that I feel like would be really good for like a dystopian movie or a horror film or something like that. You could see a movie director could, use this as like instead of having to do CGI, they could have one of these, as the demon possessed table or something. Suddenly gets up and walks away in the movie. I suppose these days the CGI is easier.
Yeah.
Well, on The Prisoner, they had the blob that would attack people. And this could be a much more, cubic, a predator.
Yeah. I kind of feel like sometimes there would be another, potential use for this. I've seen reaction wheels used to stabilize model ships, believe it or not. There was a video not too long ago where a guy put a reaction wheel on his aircraft carrier model because he didn't like how much it tipped, as the little waves or disturbances on the water.
Mm-hmm. And you're talking about side to side, right?
Exactly. Side to side. Yeah. So he just one wheel. And I think this one uses two. I'm pretty sure it uses two. This cube does. But anyway, I feel like there might be applications of this where you can build, some kind of actuator mass system into something where it's not necessarily used for walking or actual mobility, but instead to stabilize, like a robot that has two legs and would normally have tipped over, but the internal reaction wheel saved it, or or something like that. I don't know.
But this is to charge up its momentum and then suddenly decelerate in order to jump.
Right, right.
Right.
So that reminds me of the, oh, what was it called? I've forgotten the name, but it was little robots. Well, they called them bugs, basically, that had a solar muscle. No, it wasn't called that. It was basically it was a solar cell that would charge up a capacitor, and then they would dump it into an actuator.
Oh,
And
solar robotics.
solar robotics, that's right.
Beam
Oh, yes.
beam
Beam
robotics.
robots, yes.
Yes. Yes. That's
So they
right.
just sat there and sunned themselves until they had enough energy to move. I thought it was so cool.
Yeah.
I can envision a miniaturized version of this used at the
Oh,
Oh, there we go.
Oh.
$1 million
Yes.
idea.
Oh my goodness. Yes. Oh, well, you've watched these movies where, somebody has these telekinetic powers, and he'll sit there and very subtly kind of wave his finger to the side, and the die will roll, roll over one way or roll over the other way. And yeah, but you could put some smarts into the dice then, so that anybody can throw whatever they want. You just tell them, you know how people sit there and they'll hold the dies up to their mouths, and kind of blow on them for good luck, right? So they whisper, pair ones. And then, and then you throw them, pair ones, or whatever you want,
So
oh, man,
imagine having the computing power so that as it's rolling, it could subtly change its center of mass so that it wouldn't look like it had been fixed, but it would actually land as desired.
There's another movie plot item there.
Oh, that's yeah.
That's what is it? Q comes up with
Oh,
that
yes.
for
yeah.
James Bond.
Yes.
Yeah. So then there are wings.
Yeah.
And of course, you can see the one on the left there. You can see that is just amazing to me.
Now, what are they using as the power there?
Well, you see the tail.
Yeah, well, it's got definitely applying power, but what is the actuator, I guess is what I want to say.
I would have to guess that this little tab here is probably somehow when this is energized, that thing is going to vibrate up and down.
Yeah, but is it so? I think it might be a piezoelectric.
No,
yes,
I'm thinking it's a solenoid. Are we not seeing a coil wire underneath the triangular base there, just down below? If you look at the wide part of that triangle, and then just to the right of it, I'm seeing magnet wire there.
Or that could just be the wire going around to the bottom of the piezo actuator. I'm not sure.
Could be. I mean, I don't see why a piezo wouldn't work in this application. But it is interesting to note that every one of these that I have ever seen is, when they get small like that, they're incapable of carrying a power source.
Right.
They all have to be powered from a wire. I'm not exactly certain why that is, but there's some physics reason why. Once your wing gets to a certain size, the payload capacity increases to the square, whereas so that it exceeds the weight of the payload of the batteries, and as you go the other way, then it gets bad.
Well, you could imagine one of the reasons is they want to be able to test with the thing, and so you might be able to build a platform that had enough power to operate, but only for a short time. And so by wiring it up, they can test over a reasonable time.
Well, and you see that with drones too, right? I mean, the small drones have very short flight times, and the larger drones, you would think that the larger drone needs more power, and yet the larger drones have longer flight times.
Okay, so this is a video of this particular thing. I went and all right, come on. Got to have all the
Solar powered. Oh, so this does carry its onboard power.
Huh. And then it uses
Oh
actually,
no, it's got a wire hanging to the top.
yeah. Just got to make them wires smaller so you can't see them.
Oh man, I was hoping I wanted to be proven wrong there, but I have never seen one of those that actually carried its own power source. Never once. I saw one where they had it was a solenoid activated coil, but they were transmitting the power wirelessly. So basically they had an AC magnetic field where they were pulsing and then the coil was picking up the power out of the air and pulling in the thing.
Imagine like you could use Helmholtz coils, which
Yeah.
are multiple feet in diameter and have a good amount of space between them where you could actually move the robot.
Yeah. Yeah. And the other question I have is, I mean, these little guys are cool as heck, right? I love looking at them and everything, but like, really, what is the actual use of those? I mean,
oh, stop it!
I'm sorry, guys. I shouldn't. I mean, basically it's like a spy agencies. The only people who are working on these are,
Yeah.
Now, is that it looks like it might even be just a single actuator, but it moves out in both directions at the same time.
Little mechanical computing going on there.
Yeah.
Oh, he's got water on his eye.
The other thing that I'll say from all of this is it really makes gnats very impressive.
Yeah.
I mean, think about it, right? Like, we can't make something that's orders of magnitude. What we're making is orders of magnitude larger than a gnat, and we can't get it to carry around its own power supply, and yet the freaking gnats will not stop.
Ooh.
Yeah, or the dragonflies. Yeah.
I really think roboticists are some of the few people on Earth who truly have a solid sense of wonder about living things, right? Like, try to explain to a venture capitalist why walking is super, super impressive, right? Yeah.
Yeah. No, you're right. Because it's we appreciate and when somebody builds a machine that can emulate some of these things, we're actually impressed, because we know how hard it is.
Like I don't think engineers who don't work in the area are impressed, and I don't think that the people who work in biology are impressed, because they're both used to, they don't see it, right? But when you we see when you cross from biology into robotics. That's why, like Festo, every one of their videos just blows me away, and I get so impressed, and nobody else understands why I'm so impressed.
Right. So speaking of Festo again, so I don't remember which video I clipped for this one, but that upper left guy there. So you've got these undulating, what do we call them? Flippers, I guess, or
fins, maybe fins.
Fins. I don't know what the best word is. Yeah. So you've got they move. The undulation moves from the head to the tail in a continuous manner, and the thing moves as a result of that. And then of course you've got the fish, and then you've got the kind of a manta ray type of emulation. So
now that upper left one reminds me of the Strandbeest. That uses that to power to inflate, or not inflate, but to pressurize 2-liter bottles, and uses that to
yeah.
Well, let me
Ooh, there it is.
There was an aquarium in Japan that put a robotic shark in the tank with the rest of their regular fish.
Ooh.
And apparently the patrons, the people who were visiting the aquarium, were very unimpressed.
Oh.
I don't really understand what the cultural thing is there. I mean, I would love to see it, but I guess the way that they played it off was they were trying to point out that, you know, there's a bunch of sharks that are endangered, and you know, we should be preserving sharks, not killing them, and that sort of thing. And they're, you know, saying that soon there'll only be robotic sharks available.
Yeah.
And the guests were like, yeah, we came here to see a real shark. Show us a real shark.
So that thing, it looks like it's like a little like a complex crankshaft mechanism on the inside there that's making that thing work.
Yeah, rather than individual actuators. Yeah, it's once again mechanical computing.
Yeah.
And then I think that one can actually crawl up on the land and continue moving as well, if I remember right.
Oh, I'm sure it could. Yeah.
As long as you can, you know, not have the high-sided, right? You have to get the body up off the ground in order to move.
Off the ground, yeah. I think maybe this one can't, but I've seen a version of this that was able to.
Yeah.
Got on the right there.
Yeah. So then, and so you've probably seen that one. It can stick to the wall. It uses these propellers on the top.
Oh, just to push itself to the wall?
Yeah, it actually pushes itself against the wall. Now, I don't recall if my, let me see what my video is here. I don't know if I got a video. I could probably find a video of that one. Oh, that's interesting. Oh,
dancing robot there.
Here, I'm going to slide this back to the beginning. So this one, so one of the, you know, what do they say? One of the problems with these walking robots, the dynamically balanced walking robots, is that they tip over, right? Well, what if you basically put a quadcopter?
Oh my God.
Then now it can't fall over, right? So but it's kind of funny. It's almost like, so what are the legs actually doing for you, you know, other than just kind of providing a general guidance, I suppose?
I'm guessing that it takes less energy to quote walk, end quote, than it does to actually lift your weight and fly. Like balancing your weight probably takes, but I mean, it seems to me like the reaction wheel thing would be the better solution. I don't know.
Yeah.
Well, I didn't get it. I didn't get the point of it.
Reaction wheels would be more. It could fail, I guess. In this, with the wing or with the propellers, you can actually recover from any situation, I think. At least to a much greater extent than you could with reaction wheels. You would have to be very careful with reaction wheels to not get way.
I think so what you're saying is that the reaction wheel adds a lot more weight, mass, and you need a lot more energy to get the same amount of force that you can get out of a tiny little propeller.
Yeah, well, and think of the failure mode with the propellers. You could lift the legs off the ground and still be all right, or at least you would slowly, decelerate or slowly move to the ground. But with reaction wheels, if you're not on top of every movement, you could fall over.
Yeah,
sure.
I can imagine a blade of grass that's too tall being a problem for the quad walk.
Oh.
Yeah.
Well, you'd have to learn to pick it down.
While I'm thinking about it, so I'll post these slides on the website when I'm done. So the slide under the title just is a Google generic search on the topic. So you can click on that. It'll bring up just a whole bunch of stuff related to that specific topic. And then of course you can select videos up on the top, and then you can find a gazillion videos, some of which might even be related to that. So anyway, just for your reference, when you're
Ah,
if you
yeah.
happen to come back to this thing and look through it. I guess I'm kind of doing over the top on Festo this month, aren't I? These you know, the one here in the upper left is actually an underwater jellyfish like thing, you know, and then this has an actuator in the bottom here that goes up and down and it flips these arms. And then this one on the right they call air jelly, which is a helium filled balloon in the middle. It's got a little pendulum in there that it can swing around with this remote control that the guy is holding and steer it. And I believe that is what the video that I selected for this one. Let's see if no closed caption for this one, so you'll just have to kind of watch.
Oh yeah.
But you know, look at this space inside the Festo headquarters. You know, here's this big auditorium-sized room in the middle of their presumably their, I don't know if it's their corporate headquarters or their research area or whatever, but what an awesome place. And they love you know, they fly any of their machines that can fly, whether they're birds or helium-filled penguins, flying penguins, I guess kind of what they look like. So if you watch that, you can see that in the middle of the right in the middle of the pendulum of the balloon there. Let's see where they get to
I
it.
think there were cranks I was seeing.
Yeah, there's cranks that are flipping it, and then if you watch, okay, there's a pendulum hanging down here, and if you watch carefully, you'll see that pendulum. There it is.
Uh-huh.
Right in the middle there. You'll notice that pendulum will swing a little bit to one side or the other side, depending upon what direction they want the thing to go. So they shift ever so slightly, shift the CG on that thing, and then that causes the flapping, which is consistent all the way around. You know, the legs are all doing exactly the same thing. The landing is awesome. I mean, is that just a what a cool way to come down, you know?
That's my favorite of the Festo robots. That one, and the other one is the Air Manta. That's the thumbnail.
This guy right here. Okay,
yeah.
Let's go ahead and play this one too, because this one is very fun.
Those two they're just so beautiful and so slow moving, and
yeah.
I just amazing.
See, and I think they're I'm not, you know, and they've got that air actuator system. I'm not sure if they may be using it on this one as well. Well, the other one, I'm not sure if they're the big air jelly there, whether they were using air actuators or just some other kind of thing. But so this thing can actually glide too, you know. So it's filled with helium, so it's got a probably, what would you say, maybe a very slightly negative buoyancy, perhaps.
I'm not really sure. I'm not sure how much helium will offset the weight of the thing.
Yeah.
But it certainly does help. And then, I mean, look at it doing flips. I mean,
yeah,
it's
just beautiful.
Beautiful.
Yeah.
Yeah. There was an outfit that made an aircraft with a helium inflatable soft wing over the top. So sort of like one of those hang glider based aircraft.
Okay.
But with the wing being two parts and then stiffened by being pressurized with helium, and run on electric motors for basically unlimited range. Yeah, and then I guess they did a water version of it, which is.
Or is that a real animal? I don't know.
Let me see. Yeah, if we get a close enough look at it, maybe we can tell. I think that's an
animal.
Yeah.
Yeah, I think it might be. Has anybody on here ever been to aquariums where you can pet these things, where they swim around and you can actually? And so we visited one. There's an aquarium down in, I believe it's in San Antonio, Texas, where you can just stand by the side of the tank, and you can. No, maybe that has always been the. And their skin has the real animals have this skin that's it's really slippery. It has this kind of I don't know, it's hard to describe, but it's like oil on a really smooth surface. It just has this really, really slippery feel to it. And when you put your hand in the water, they'll come up to you because they're kind of looking to be fed, and they don't have teeth or anything, so they're pretty harmless. But they're very cool. I mean, it's just and watching how the real animals navigate through the water. Of course, the machines are much more awkward in their movements than the real creatures, but it's really amazing. And I mean, the Festo engineers, you got to hand it to them. I mean, these guys did amazing, So as you can see, this is kind of like you can go on and on with these, the bat and the dragonfly. I think this looks like this starts a whole chain of their videos here.
What's that?
So the bat's hanging in the typical cave's position, right? Hanging by its feet.
Oh, look at those little. Okay.
And then I wonder if that, and then it releases, and then it's just. Of course, what else could they have possibly intended for this big room in their corporate headquarters? Than to, what a perfect place to fly around.
Yeah, and keep in mind that one's not using any, helium or trips or anything like that.
Nope. This thing it's just flapping its wings, doing it totally by flapping the wings. Which is that's really impressive because that's a,
What's that?
This is one of the things where I try to tell people how amazing Festo is, and I don't think they really get it, but look at every other quote ornithopter that's ever been made, and they don't look like an actual flying creature, right? They're sort of like beating the air into submission. They're not smooth. They're not graceful.
Yeah.
This thing is just graceful. I mean, it looks just like a bat or like a bird flying,
Yeah. Yeah. What a.
By the way, that the birds, they're not real. All the birds died off a long time ago, and they were all replaced with robots that the government runs. That's seriously I don't know if it's a joke or but it's like the flat earthers. There's a whole group of people who will tell you that birds aren't real.
Let's see. Let me. That's too funny.
So,
So, have you guys heard of this thing, Wave Glider?
Sure, what it is yet?
Okay,
No.
so let me show you this one. This one is.
Oh, I know what it's doing. It's using the change in height of the wave versus the anchor that it has under the water. And then there'll be a spool of wire or something between the two. That is so smart.
So wait, is it a power generator or what is it doing?
I'm assuming that they're using it for forward motion here, but it could generate power as well.
Yeah, so they put the solar panels on it that powers, like what it might do is it will carry equipment to measure atmospheric conditions, water salinity and air pressure and things like that. And something like this could be made durable enough to fly through a hurricane.
But now, is it retracting it with the airfoil or the hydrofoils angled in order to provide propulsion?
So think about it this way. That cable goes up into a spool in the main ship, right?
Right.
Okay, just so you know, I'm assuming this, but
yeah.
Oh, I see. They're doing it with the wings on the thing. What I was going to say is that the cable goes up there to a spool, and when when the wave pushes the ship up, they release the spool. And then when it comes to the, nope, that doesn't work. Never mind. Okay, so just watch the video and don't pay any attention to me.
How about this? How about this? The hydrofoils are not powered. They have angular limits, so that when the waves pull the ship up, that pulls on the cable, and they don't retract it. They deploy it, and they just leave it at a certain distance from the ship. And then when waves cause the ship to go up, then the platform, the underwater platform is pulled up, and the hydrofoils go to their limit, and that provides forward motion.
I think you've got it, Doug. That sounds right. Yeah.
And then when it goes down, I don't know, maybe it's heavy enough to go back the other way. I'm not sure how that works. How do they keep it taut?
Yeah, that makes sense. That it like they just make it heavy and it just sinks.
Could be.
The hydrofoils would flap up and not get in the way as it goes back down again. Or actually, no. They would flap up to another limit where it would glide forward as it sinks back down again.
Yeah.
Yeah.
So do you know? I don't know if you noticed on the underwater piece there was a propeller on the rear end of it, which might have been perhaps providing a tension on that cable.
So
that's providing.
By having the hydrofoils angled down and then propelling it with a small propeller, it would extend it again if it wasn't too heavy. It wasn't heavy.
I should have probably up. Sorry about that. What I should have done with this was, here, I'm going to back this up just a bit here, where they're doing the exploded view of this thing.
So this one, they're using moving center of mass to get it to do things underwater.
That's actually a pretty good way to do it. It takes very little energy to do that.
Yeah.
And then you just glide up and glide down, taking a little bit of your vertical motion and translating it into horizontal motion with your hydrofoils.
Look at that. So this so they ship down a mission basically into the brains of this thing, and then you've got that little weight there that can move forward and backward.
It's
so it
the
looks like
they're using the battery as their ballast.
Yeah. See, now it's and now that causes it to sink. So this is okay. This is actually a different device then. So this is something. Okay, so there's the kinds of things that this thing measures. And when it gets down to whatever their program depth is, then it slides that forward, that weight back to where it's balanced. So that goes back. Yeah.
But now how does that make it want to come back up? It makes it flat.
Well, it doesn't. Once they get to the bottom, then they shove the weight back.
Yeah.
Right.
Yeah.
But that still doesn't explain why it goes down and up.
Good question. Maybe they are compressing air as well,
So there was a bladder in the tail there that looked like it has to do with changing the buoyancy. So I think they're not only changing the CG of the thing, they're also changing the buoyancy of it to get it to go up and down.
Okay. Oh yeah. Well, That's not a bladder. That's the wing, isn't it? Or maybe that's the bladder. You're right.
I think it's a bladder, and then that causes the nose to dip into the water, but then the tail goes up,
right.
and then that now the antenna is out of the water where it can then communicate its data and then also get new instructions.
Right.
So this is a little different kind of a mechanism, but the neat thing about it is how little energy a thing like this can use. I mean, this thing sounds like this thing can go for what, months? You know, who knows how long this thing can operate? Because it would okay, it needs power to go to do what it, you know, to power the internal electronics and all that. So it's got to have some kind of a battery in there, but the amount of power that it actually draws from that battery is probably pretty modest. And so that this thing, it maybe could go for weeks or months between charges. At some point though, it would have to be retrieved, plugged into the, you know, ship comes out, picks it out of the water, plugs it into a charger, recharges the battery or changes the battery, depending on what kind of battery it is, and then drops it back in the water and then sends it off for, you know, a new set of missions.
So the two actuators, a compressor and some sort of a linear actuator, can both be made in such a way that they can be very low power. They just take a while to do their job. And that's
Sure.
okay because it's going to be spending a long time underwater, just statically moving, basically. Or what do you call it? Moving without an actuator.
Yeah. Either it's either sinking or it's rising back to the surface. You know, just following that kind of a sinusoidal sort of a mission profile. Okay, let's see here. I think I'm almost to the end of this thing. Let me gerbil
How does
ball.
the robot gerbil ball work? Are they moving the center mass, or what are they doing there?
Yeah, with this guy, I think you've got there's a servo. There's one servo is tied to this axle that goes through the center of the gerbil ball, and then the other servo is rigged onto it such that it can rotate itself a certain amount around this thing to cause the CG, the internal CG of the ball to shift, and then it goes in that direction. Now somehow though it can't be hard attached to that axle, I don't think. Well, let's see what the video shows here. Oh, this is okay. Guard ball. Yeah. See if they
Guard ball.
Oh, I think they might show a little bit of the innards of how this thing works. So I'm guessing that this thing is being remotely controlled. Somebody's just driving it.
Mm-hmm.
Going on the water.
You can see it through the clear balls that the innards are despun.
Yeah. So in that case, you know, you put them, when you put them in there, you could have them. Let's see. You well, again, if you had the ability to just like shift a weight to force the CG off axis, that will cause the ball to start rolling in that direction.
Right.
The further you shift it, the faster the ball will go, and then when you want it to stop, you pull that weight back toward the center. All right. Well, I don't see, it looks like just lots more videos of the thing in various scenarios there. Don't see, okay, look at guardbot.inc there, or guardbot Inc, I guess, if you're interested in digging into more what that thing is. But
I think you're right. If you can rotate the center of mass, you basically use the batteries as your ballast, and you have them low on close to the surface of the ball, and then you rotate the ball around that. That gives you the forward motion, and then maybe tilting the center of mass to either side allows it to turn.
Right, and it's kind of that's the same thing that air jelly really did the same thing in terms of how it was able to move the balloon in different directions, because there was just a weight that hung down, maybe 3/4 of the diameter of the balloon inside. And then they had a sort of a multi-axis servo mechanism where they could cause that weight to shift a little bit to the left, a little to the right, a little forward, or a little backward. And depending on which way that weight went, that's the direction that balloon would tend to go. Yeah. Whoops. And BB-8, of course, I think this is just a video of somebody that built one of these things, and they kind of talk about the construction of it. And of course, this is, again, similar technology inside to with rollers, usually rollers on the bottom of the head, and then a magnet on the inside that causes the head to stay attached. But then the magnet inside is floating in there such that it stays in the same relative position, relative to a point on the outside, like in this case, the head, and then the ball rotates underneath. I've always thought,
that I've never really understood what the point of this is, other than just it's cute as heck, right? I mean, it's super cute and fun, but
right. Yeah, people, I mean, fans of these Star Wars movies, they just kind of go overboard building stuff like this. So here's an interesting scenario. Okay, so this little guy, he's rolling around on a desert planet that's got sand on it, right? And sand tends to kind of cling to things, and things that move generate a bit of static. You get sand and dirt and stuff, and that stuff is scraping underneath this head.
Right. Like, how long is that really going to work?
Exactly. Yeah. So this is I'll kind of skip ahead to the, see if I can get to it here. So this is, come on. Okay, and there's all kinds of cool stuff that people at Maker Fairs like to build.
Man, I miss the big Maker Fairs.
Yeah. I don't think this one, I don't know that it was quite there yet. Okay, so that you see the magnets, there's magnets on top of that the 4 little round magnets on there. So that's where the head sits. And then you can see they can twirl it so they can make the head spin. And then obviously you can shift. Yeah, so she can shift the CG on the thing then to get it to go, go in whatever direction. Oops. Oh, I got it. Okay. But you can imagine, keeping this thing clean enough so that, you start getting sand between the head and the surface of the disc, then you could easily get binding. And okay, so there's a.
Yeah.
So there's your
So this is moving similar to the last one in that
Yeah.
they only have one axle. So they can't really rotate the ball in any direction, but they can steer like a car basically going around a corner.
Yeah.
Or like a
By
motorcycle.
shifting the mass, yeah.
Yes.
Yeah. Yeah. I mean, that's a really pretty impressive piece of engineering there. It's a
There's a lot of little pieces parts in that.
yeah. Yeah.
And to think, I mean, all of that engineering and work all done just because it was inspired by by some movie.
It's a cute movie.
I'm sorry. Please don't kick me out of the group just because of Star Wars. I don't know if there's any Expanse fans out there, but
Yes.
that's the one.
I'm still reading the books.
Oh, are you? Are they? Or do you think they're worth reading? Or
Oh yeah, they're just great.
oh, I need to do that.
I do believe, yeah. This is the last one. I know we're hitting. Oh my, we're definitely way over time here, but we'll go ahead and hit this one. Have you guys seen this one?
No.
Pictures of this thing?
No, I don't think so.
Okay. Well, this is.
So this is again like a rolling robot.
Somewhat, yes. They call it shape shifting. So shapeshifter.
Oh,
You can fly in
okay.
the sky.
Oh.
So it
What is
deforms
the
in order
cylinder?
to move to the next face.
What does the cylinder have to do with this?
Well, I think there's a continuum, right? Like they started off with the original shape, yeah,
Oh.
and now see they've trained that just goes in one dimension, but then they turn it into a ball and it goes in all dimensions.
Yeah. So the idea would be to create something that could shift into whatever was most useful for the environment, the terrain that it had to encounter.
So let's see, that's a dodecahedron, right? So is it 20 faces? So you have that? No. 12 faces for a dodecahedron. So there'd be 12 robots basically, each of which could fly, but they could also congregate into a sphere.
Mm-hmm.
That's interesting. That reminds me of they're starting to do drone carriers now, where there's one big drone with a really high energy storage. Like for example, it's gas powered or other hydrocarbon energy source, and then it carries a bunch of little electrical drones that charge while they're in flight, and then can disperse and go and do jobs and then come back and land again. And actually, that matches perfectly with the Slaughterbots video. If anybody hasn't seen the Slaughterbots video, you really should go and watch that. There's a scene in there where the large drone blows a hole through the side of a building with a shape charge after carrying the small drones to the building, and then the small drones fly through the breach and go in and pick off the individual victims.
Oh man.
Not that I focus on dark uses of technology or anything.
Right. Of course not.
The one thing that's cool about that too is it's very lightweight, right? While also being sort of a robust circular shape. So you could imagine that, for example, like surviving a windstorm or I don't know, whatever problems you might encounter on some other planet, and then still being able to move.
So each face is a quadcopter.
Yeah.
Wow.
With probably a different type of machine underneath. Different type of with a different application or different.
Like specialization. Each one of them is doing a different little part of the total package.
Or just having multiples so that if you have a failure,
Redundancy.
Redundancy, yeah.
Yep,
I wonder
yep.
if the quadcopters can be individually powered so that it can roll the ball. I guess that makes sense. Unfortunately,
Yeah,
they
why
can-
not?
they
Why not?
propel they don't actually have that much of a component. Maybe if one of each or something like that blows, one of the four, so that it is off center, so that it can actually roll in a direction.
Yeah.
And actually, there could be some reaction wheel action there as well, right?
But
Yeah.
where would that'd be an extra piece in the middle? I don't think there's any extra piece.
No. I'm saying use the
Oh yes, I see what you mean.
rotation of the propeller as a reaction wheel. It's not a very big one, but like you could combine all of the rotors that happen to be in a certain plane on like either side,
Right.
and spin them all in the same direction, and it would probably jump or move in some way.
Wow.
So
that's we went a lot longer than I was expecting, but you guys just kept going. So I was like, okay, that was fun. What'd you think? That good? Yeah, good time. Yeah. So
and I didn't even bring up cable bots and Skycam, and
I know that's yeah.
Like I said, is this the first meeting that I haven't mentioned Cable Robot? Oh, darn.
Yeah. That's because that's right. I mean, when you get right down to it, this is kind of like there are so many. When you start to mix and match things, the number of permutations it starts going up exponentially. Because you put a little of this together with a little of that, and then all of a sudden now you've got something entirely new, like the walking robot with a quadcopter on top. Okay, now you're combining two different kinds of mobility, and the advantages and disadvantages, and
we saw combining two different types of wheels.
Yeah,
the round wheel and the spike wheel, and you make them into one wheel.
Yep.
And we saw combining small drones with large drones. We saw shape-shifting one. That's another one where you're combining different types of robots.
Yeah. You can just it's kind of like there's kind of no end, right? I mean, you just whatever you can imagine is probably possible. Not necessarily feasible, but it's at least possible. Oh. All right. Well, that was all I had on this. I thank you guys all for hanging in there with me. I think it looks like we might have lost one or two people over the course of that. But if anybody wants to go back and watch the video after the fact, that'd be good. Anything else that anybody thought of? Any final questions or anything from any of the previous stuff, the announcement parts at the beginning of the meeting? Was there anything that anybody thought of they wanted to make sure we got out here?
I just want to call out, I'd really love to see another machine vision presentation from Bob. Really enjoyed that. Thought it was great. And Bob, you promised that you would do another one. If Bob's not here, man.
Well, no, he is actually. I think so. Well, actually, did he drop off?
No, he's still there, but he's there he is. He was off getting coffee. So Bob, I was just calling you out on your promise to do another machine vision. Thing. Oh, now you can hear me.
Now you can hear. Okay. Now do it, James.
Third time around. I was just calling you out on your promise to do another machine vision presentation at some point. I was hoping you would do another one if I encouraged you.
Yes, I was planning to. So probably something like video odometry or something like that.
Ooh. Oh yeah, great nice stuff.
That's kind of useful.
Yeah. I would especially also like if you can get into the like nitty-gritty implementation details.
Yeah. That's my plan.
Sometimes that's a little bit confusing for me. So.
Yeah. Well, I got a slot in May, Bob. You'd be happy to slide you in there.
It's good to have a deadline, Bob.
Or you want to think about it and get back to me?
Yeah, because I'm going to be gone most of February and March, and so I have to build a few things first.
You have to build some things. Okay, why don't you just let me know? May on is currently open, so any time in that time frame.
Yeah.
Okay.
And then
awesome.
The other thing is, I don't think that. Oh, he's not on here, right? Oh, jeez. Oh, I hate it when I do this. This old brain of mine. I just did that. I just did that thing where I have somebody's name in mind, and I'm waiting for a second, and then the name's gone.
Yeah, it happens all the time.
He gave the presentation on behavior trees and whatever.
Oh,
Greg?
Huh?
Was it Greg?
Greg. Yes. Greg.
Yeah.
Gave the presentation on behavior trees, and in it he said he was going to open source the code. And he hasn't open sourced the code, so we all need to gang up on him and bug him to open source the code.
Yeah.
Because I want to make use of that. I think that's really good setup.
Okay. Yeah, so we need to ping him about that. See, in fact, he's usually at the meetings too. I was surprised that he wasn't here.
Well, it's the holidays, right? He probably had family stuff to do.
Yeah, I suppose so.
It's a small meeting this time around.
Okay, I'll try to. I made a little note to myself there. Maybe I'll try to ping him and ask him about that, and then see if he's open to do another chat on something that he maybe touched on in this last presentation, wants to kind of dive into a little deeper, because that was good. That was a good talk too. All right. Well, we've probably gone so long here. I don't know that we necessarily want to stretch this meeting out anymore. We're already at 2 hours and 50 minutes. So I think we'll just call the meeting, and we don't need to have a post discussion, because I don't know about you. It's almost 2:00 and I haven't even had lunch yet. So
yeah, I need to go get something to eat. And happy holidays to everybody. Always love you.
Yes.
Same to you. Take care.
Yeah. Glad all you guys. Okay. Take care of yourselves.
Quick question. It looks like you have an intention to return to hybrid meetings at some point. Can you give an update on that?
So, that would be something when Lloyd is here. That would be something that would probably have to kind of talk with him about, because I used to run them when I lived in Washington, and I live in Idaho now. So, we could do hybrid meetings if you guys want to all drive over here to Idaho for the day, So, at this point, we haven't had a lot of people coming and saying, "Hey, can we do this?" We've just kind of had a few people, and these online meetings are a lot easier to run than a hybrid meeting is. So, but that's not necessarily the reason for not doing them. We do need a venue that can probably handle 25 to 30, 35 people or so. And the first field house where we used to do our meetings year round it's only available about 6 months of the year. So that means that we would probably have to switch meetings from one location to another location while First is using that facility. So, or find somewhere else where we could do these things for 12 months of the year. Most public venues we've looked at, like public libraries and that sort of thing, they don't want to book out their facilities for that long. They're happy to do it for a month or two at a time, but they won't do it for longer than that.
So you end up chasing them every month to
So then, on top of putting the meeting itself together, we also got to figure out where is it going to be, and then we got to get the word out to everybody, and so it ends up being a lot of logistics behind the scenes to make them happen that way. So,
have you ever managed to run a hybrid meeting, Steve, that actually worked? I've never seen one that worked. It's really difficult to get the people who are physically together to not talk to each other, which then disrupts the meeting that's going on online. Yeah. And so it's better to just do a physical meeting for the people who want to do a physical meeting, do a hybrid meeting, or do an online meeting for the people that want to do an online meeting. And then maybe record the physical meeting so that people online can watch it after the fact? Or...
I guess that would probably be the best way to do it, because it creating an inclusive hybrid environment is actually pretty expensive, at least from my experience in looking at the technology that's out there, to where you could literally see and hear, as online participants, you could see and hear all the other people there. And
now what we can do, Steve, here's my brilliant idea. Okay, let's get a bunch of old Roombas and some music stands and cheap cell phones, and we'll make telepresence robots for all of the hybrid people. So there's got to be like 10 of them, or 20 of them, right? We'll put them all together, and then we can have a meeting where there's hybrid people walking around, or what there's robots, telepresence robots walking around interacting with the people at the physical meeting. That
I thought of that. I thought of that at one point, and it was like, that would be pretty slick, because you could literally interact individually, even and if these things are all independent, you can take your robot and drive it up to whoever you're interested in chatting with, and you could sit there and have a one-on-one with that person, and then somebody else could do the same thing with somebody else.
Right, and all you need is amazing Wi-Fi connections to handle all the bandwidth.
Yeah, that could be interesting.
Was it RoboCops that did that in the movie?
I don't remember.
Oh,
I mean, it's certainly some version of that has been done in science fiction movies, but
if you had, it's if you have having a big group of people, having a big group of people in a room, and then being able to hear and understand and see what they're doing is up, without having some guy with a camera basically walking around the room. Okay, this person's talking, they're showing off this thing. So then you got to go over there with the camera, or you have a place where, okay, you want to talk about something, you go and you sit at a desk. Maybe there's a camera on you, there's a camera on the desk. You can bring whatever it is you want to show off there. If you've got online stuff you're trying to bring up, then of course you need a computer there that's also connected to the meeting, so that everybody can see what you're showing on the computer as well as the cameras. Yeah, it ends up being.
My real life experience with this is there's a get together in Pasadena, California. The people come from all over. There's people that come down from Washington. Called Hackaday SuperCon. So the Hackaday.io or Hackaday.com is a great organization, and then they have the SuperCon once a year in 1st of November.
Homebrew Robotics out of San Francisco does a hybrid meeting. They do. They have meetups once a week for some of their breakout sessions. Very active. They're seemingly successful at it, but it's like you described. They have one central camera up front. They have a big screen, so everybody can sit back and watch. And if you want to get up and say something, you've got to get up and move up to in front of the camera and mic.
Yeah. So Craig, where are you located?
I'm in Lakewood, which is just
south of Seattle. Yeah. So you're kind of in that area. So the probably the easiest way, if it was going to happen, the easiest way that it would be implemented would be not as a hybrid meeting, but as a recorded meeting with the videos then uploaded and posted. So, but then I think what I would propose as an alternative would be, rather than discontinuing these video meetings, is to continue these video meetings, but then add in maybe even quarterly, let's say, maybe once every quarter, have an in-person meeting somewhere, so that people can get together in person, and those meetings get recorded. Those get added into the mix, so you've got these monthly meetings that are always there, and then you've got these quarterly meetings that people can get together and hang out. And I truly miss that. I mean, my garage is just overflowing with stuff that I would just love to give to you guys, but it's a long drive. It's 500-mile drive. So
No, I would second that one. It's just continuing on with our monthly meetings this way, and then have like a quarterly meeting, which was a get together.
So right now there's currently like 2 Robothon events a year that are planned, and so possibly incorporating. It might be interesting to see if we could incorporate that into each of those events, so there would be a kind of like a mini SRS meeting piece that's a part of the Robothon event, so people can just get together and talk and share about robots, and then add two more meetings in between, so that you got one a quarter. So okay, well that would be something. There's the next Robothon committee meeting is happening in January, and we're going to be talking about the merchandising stuff as part of one of the agenda items, but I can also bring up some of this stuff at that time as well, and see if there's some interest, and if somebody has any solutions as far as well, where could we do these things, and maybe Sunnycrest High School, that I mean the school is obviously available on weekends. Most schools do have availability on weekends, and maybe it wouldn't be a big deal to add a couple more dates in there, and then people can just get together. And so it's an interesting idea. I think I'm pretty sure there's a lot of people that do miss getting together face to face, shaking hands, seeing each other in person. Yeah. So okay. Any other thoughts on that? Just shoot them off to the Seattle Robotics Society Gmail. Any other ideas or thoughts or whatever comes to your mind, and we will we'll see what we can see what we can make happen. That sounds really cool. I think that's bringing all this together. It's kind of like I hadn't thought about that before, doing it that way before, and it's like that could work.
Yeah.
Because the other way, like having access to a really nice video conference room, like let's say Microsoft up in Microsoft headquarters or something like that, one of these places that's got the $250,000 fancy multi-camera microphones everywhere, microphones around a big table, video that tracks speakers and all that kind of stuff. You need a place. You would literally want to have a place that's set up like that all the time, and you could just go there and do it. But at this point, the SRS isn't quite that rich. So
I know that Microsoft does have a couple facilities like that, and some that are not quite that good.
Yeah,
but we use them for IEEE meetings all the time.
Yeah.
That's
over the east side, right? Over their big campus over there. So
yeah.
I don't know what we would need somebody who has an in over there that could chat with somebody about, well, what would be the options for utilizing a space like that, or if that even if we decide just Sunnycrest High School with a video camera, that could do the trick, really. Just record the meetings. They're recording all the rest of the video for all the contest stuff. Let's just have a camera set up and capture what people are chatting about and put it online.
Yeah.
Okay. Well, thank you so much for the idea. That's a cool one. Yeah. We'll see what people have to say about that. See what they think, and I would definitely be willing to assist with that if I wasn't so far away.
Well, thank you for the presentation. I saw several ideas that I had never seen before, and add some creative juices to the mix.
Yeah. Well, good. I'm glad that that's the goal. Kind of stimulate those imagination and ideas and stuff. So good. All right. Well, thanks, Craig, for joining us, and Doug and James and Robert and Bob and Scott and Dick. So we'll don't know whether I think we're my wife and I we're going to do it. We're doing a cruise in the Caribbean cruise next month, so I don't think I'll make it. I think we're going to be out down in Florida at that time, or out in the ocean. So we'll miss you guys next month, but either Lloyd or Chaz will be here to make the meeting go, and then facilitate the what do they call that? The robot builders panel. So do come for that, and have a great Christmas and a happy New Year, and we'll see you guys around.
Okay. Have a good one.
All right.
Merry Christmas,
Yeah.
everyone.